You and I, we think of time as a one-way street, right? The past is done, the future is what's coming. But what if that's not the whole story? What if the most solid, most fundamental theory we have, quantum mechanics, is hinting that the future can actually reach back and mess with the past? Yeah, today we're diving into an idea so radical it might just flip everything we think we know about reality on its head. I love this quote. It just perfectly sums up the beautiful mess that is quantum physics. It's been 100 years, and for all its incredible power to predict things, nobody, and I mean nobody, can agree on what it's actually saying about the universe. This isn't some old, settled argument. It's a debate that's happening right now. And that right there is the huge paradox we're digging into. Look, quantum mechanics works. It works so well it's almost magic. It's the reason your phone works, the reason computers exist, pretty much all of modern tech. But the moment you ask a physicist, okay, but what's really happening down there? What does reality look like at that level? You suddenly get a whole bunch of completely different and sometimes contradictory answers. So, okay, where does all this weirdness even start? Well, it pretty much all comes down to one single, deeply strange concept. Think about an electron. Before you measure it, it's not in just one spot. It's more like a ghost, a cloud of every place it could be, all at the same time. We call this superposition. But the instant you try to pin it down, the moment you measure it, poof, that cloud of possibilities collapses into one single real location. And that's the 100-year-old mystery, right? What is that collapse? And why does the simple act of us looking at something seem to force the universe to pick a side? To try and answer that question, physicists have come up with some of the wildest ideas you can possibly imagine. Let's take a look at just how not on the same page everyone is about this. Okay, so this chart tells you everything you need to know. There is absolutely no consensus here. A poll was taken at a big quantum physics conference, and yeah, the old school Copenhagen interpretation has the most votes, but it's not even close to a majority. You've got huge chunks of scientists backing completely different and way wilder ideas. This is not settled science, folks. It's an active, raging debate. And what's crazy is just how different these ideas are from each other. So the classic Copenhagen view, that's the one that says the quantum weirdness collapses into the one reality we see when we look at it. Okay, fine. But then you have the many worlds idea, which says, nope, there's no collapse. Instead, every single time a quantum event could go one way or another, the universe splits. So every possible outcome happens just in its own separate parallel universe. I mean, think about that. It means there's another universe where that electron landed somewhere else entirely. It's a mind-bending concept. All right, so we've got this huge puzzle about reality. But now, let's switch gears a little bit, because it turns out this is all tied to an even bigger, even more fundamental mystery: time itself. Here's the thing that's bothered physicists for ages. If you look at the most basic laws of physics, we're talking everything from Newton's laws to Einstein's relativity, the math doesn't care about the direction of time. You could run the movie forwards or backwards, and the equations work just fine. A video of a planet forming from dust would look just as valid, mathematically, as a planet exploding into dust. The laws themselves don't seem to have a past or a future. So that brings up the big question, right? If the laws of physics don't care about direction, why do we? Why do you remember yesterday but not tomorrow? Why do we see eggs break but never unbreak? For a long time, the go-to answer was something called entropy, the idea that things naturally move from order to disorder. But what if that's not the full story? What if the real reason for time's arrow is buried deep inside quantum mechanics? And this is where the story takes a really interesting turn. Because it seems that old assumption that all the fundamental laws are perfectly symmetrical in time, well, it might just be wrong. So a couple of physicists, John Donahue and Gabriel Meneses, have pointed out something crucial. They say, hey, when we talk about the laws of physics, we're leaving out a piece of the puzzle. And deep inside the math of quantum mechanics itself, they found a hidden direction. It's not really an arrow of time, but an arrow of causality. So what you're looking at here are Feynman diagrams. It's basically how particle physicists draw what's happening when particles interact. And what the math behind these diagrams shows is that these interactions are not symmetrical in time. There's a rule baked in that says positive energy has to move forward in time. It's this subtle little thing in the equations, but it's a huge deal. It's an asymmetry right at the heart of the theory. And this isn't just some abstract idea. It actually comes from this tiny little piece of math You can almost call it a fudge factor that physicists have to put into their equations to get the right answers. But here's the thing. That little fudge factor has a massive consequence. It's what makes sure that cause always comes before effect. It literally forces a particle to be created before it can decay. You can't have it the other way around. So it seems like quantum mechanics itself inherently knows which way time is supposed to flow. Okay, so if quantum mechanics is what gives time its direction, could that fact help us solve its other big mysteries? This brings us to the final and honestly most mind-blowing idea of all, retrocausality. The idea that, yes, the future can influence the past. So let's put this crazy idea to the test. Can it solve the most famous quantum weirdness of all? I'm talking about entanglement. You've probably heard of this one. It's the thing Einstein called spooky action at a distance. Basically, you can have two particles that are linked together, like a cosmic pair of twins. You can then separate them, send one to the other side of the galaxy. The weird part is, if you measure something on particle A, you instantly know what the measurement for particle B will be. Instantly. It's as if a signal is traveling faster than light, which is supposed to be impossible. But retrocausality gives us a bizarre but elegant way out. What if there's no faster than light signal at all? What if, when you measure particle A over here, that decision sends a signal backwards in time to the moment the two particles were first created? Then that information travels forwards in time with particle B. So by the time you measure B, it already knows what's going on with A. It's this crazy zigzag path through time, and it completely gets rid of the spooky action. The only catch? You have to accept that an event in the future can cause something in the past. And that brings us to this really powerful question from the philosopher Hugh Price. We just assume that the past affects the present, right? That's obvious. But why do we automatically assume that the future can't? Why do we think particles should only know about what's already happened, but be totally blind to what's coming? Are we just forcing our own human perspective onto how the universe actually works? And that's really the final, biggest question of all. What if this feeling we have, that time flows in one direction, that there's a difference between a memory and a dream of the future, what if that's just us, a feature of human consciousness, not a fundamental feature of reality? What if the universe is really this giant block of space-time, where the past, present, and future all exist all at once, and things can be influenced from both directions? It's a pretty wild thought for sure, but it might just be the key we've been looking for to finally make sense of this wonderfully weird quantum world.